Today I'm going to deconstruct the project for SES, Energy in Everyday Life. Before me, I have an orange battery and I have a potato battery, which are both being connected by the medium of this aluminum foil to the orange battery. I'm going to deconstruct them as the project is already finished, and I'm going to start by removing the binder in between these two batteries, simply showing the potato here. Now, something worth mentioning for this project is that I used shinier foil, something with a glossier finish, if you will, than I did on the orange. And unfortunately, I feel like on the camera there's a lot of glare, but visibly I can see in front of me that this one's a bit shinier than the orange flat one, and I feel like that may have yielded, in turn, some different type of results. So, I just want to start by showing that I built the potato battery, which I surprisingly do feel just inherently a little bit of something, just some spring, as a matter of fact, in the foil, which is great. Here, displayed, we have the less fortunate orange battery, which unfortunately I have tried time again, but I have not been able to get this foil in the right location. However, I did not feel that much electrical impulse on the orange as opposed to the potato. I felt it was more successful with the potato than it was with the orange, and that is really funny because this is made of citrus. So let me just deconstruct what I did. I first began by attaching the penny to the foil via the paper clip. I then inserted that into this incision that was made onto the orange, but that was not before I put this penny in here. So this was the second electrode. This piece of foil was the last piece in the equation, which was used to connect to this other non-existing piece of foil, which I touched my finger to. Same thing with this one. See, as you can see, this one has more spring in the foil. I'm not sure if that has to do with any of the electrical charge or just has to do with the side of the foil that I actually used. However, I feel like this one was more successful in transferring energy, being a battery, if you will. In order to do that, the first incision that I made was here, where I inserted the penny, and then the foil into the other side of the potato. I then proceeded by putting this here, this penny, into this potato at that point in the incision. Also attached it to the paper clip and inserted it so. The last part of the process was putting this electrode here, so that I could, or rather not electrode because this is not copper, but inserted this here to go to the other side. So there is this. Here's some things that are worth mentioning as concluding part of the projects. I believe that this part of the aluminum foil that was shinier worked better, and I'm not sure, but for next time I will definitely use that shiny side. I'm not sure if me having this duller side resulted in the diminished effectiveness of the orange battery as opposed to the potato battery. And I'm going to answer some of the questions and extras at the very end. Which material is the positive and negative charges of your battery? I believe the positive charge is probably coming from the copper. The negative charge is coming from the foil. If you have a voltmeter, measure the voltage and the current of your battery. What is the power produced by your lemon battery? I do not have a voltmeter, unfortunately, so I cannot fulfill that question. How many lemons would it take to equal a car battery? The order of magnitude estimate only. I will leave that answer in the description below. Different types of metals as electrodes, or try different types of metals as electrodes for your battery. So as mentioned before, I used a sheen side and I used a rough side, and I found that the sheen side was more effective in getting energy from the battery. Different types of fruits or vegetables as electrolytes for your batteries. Okay, well, this orange was the second project. The first project, which is the more successful one, used this potato. And if you have an LED, which I do not, available, investigate how many lemon batteries are needed to light it. Okay, So I may investigate how many lemon batteries are needed to light that, and I will leave that as well in the description below. In the chances that I can find one around my house, which I most likely won't, but I definitely will look. Anyways, that concludes the rest of the video. Thank you so much. As I said before, the order of magnitude estimate will be left in the description below, as well as the rest of the answers to my questions, just in case I made any mistakes. Thank you so much for watching this video and taking the time of your day to view me doing what I love, which is school during quarantine. Have a nice day.